Chapter 8, Right Triangles. Today we're going to cover section 8.6, sine and cosine, day 2. Your class opener. Find the values of x and y to the nearest integer. In an isosceles triangle, the altitude to the base is the perpendicular bisector of the base. So here's what I'm looking at. If you know that a triangle is isosceles, if you see that the altitude is drawn in, then you should know that the base ends up getting bisected. So problem number 6, find the values of the variables. So based on what I just said, I see that this is an isosceles triangle, and I see that y is the altitude. So the base of 24 I know is going to get bisected, and each side is going to be 12. So if I want to find the values of x and y, I'm going to write down my phrase SOHCAHTOA. And let's see what's going to happen. Let's try to find the x value first. And I know that I have to deal with the 65-degree angle. The only side length I have is 12. So from the 65-degree angle, 12 happens to be adjacent. X happens to be the hypotenuse. So if I have adjacent and hypotenuse, I'm going to deal with the cosine. So I can set up the cosine of 65 degrees equals the adjacent over the hypotenuse, which is 12 over x. I know I need to get the decimal value for the cosine of 65, which is going to be 0.4226. If I cross multiply, I'm going to get 0.4226x equals 12. Now just divide each side by 0.4226. And let's see what happens. So 12 divided by 0.4226. And if we are rounding off, looks like we should get 28. Now let's go back and find the value for y. So I still know that I have 12. I'm going to now use the fact that I still have to use the 65-degree angle. I'm going to use the 12, and I want to find the value of y. So 12 is still adjacent. The y happens to be opposite. And if I'm using opposite and adjacent, now I'm going to use the tangent function. So tangent of 65 degrees equals opposite y over adjacent 12. And I need to find the decimal value for the tangent of 65, which is 2.1445. And now if I cross multiply, we get 2.1445 times 12 is going to round off to 26. Number 14. A guy wire is attached to the top of a 75-meter tower and meets the ground at a 65-degree angle. How long is the wire? So if I draw myself a simple picture, I can imagine here's some tower that happens to be 75 meters tall. There's a wire that goes from the top of the tower to the ground and makes a 65-degree angle. And we want to know how long the wire is, which is out here. So first thing I'm going to do is write down SOHCAHTOA and look at the values I have. So I have my 65-degree angle, the 75 meters, and x. So from the 65 degrees, the 75 meters is opposite. X is the hypotenuse. So if I have opposite and hypotenuse, I'm going to use the sine function. So sine of 65 degrees is going to equal the opposite, 75, over the hypotenuse x. And now I need to get my decimal value for the sine of 65, which is 0.9063. And if I cross multiply, I get 0.9063x equals 75. Divide each side by 0.9063. So 75 divided by 0.9063. And it rounds off to 83. So I know that the wire is 83 meters long. And your closure. What was the most difficult part of today's lesson?